So yesterday we have comparing the difference between IoT stack and the your TCP stack. So TCP/IP, as I mentioned, TCP/IP, these are the two different kinds of protocol, and with the help of these, certain rules have been decided. Some layer-like structure architecture have been developed. So IP is an internet protocol, so it is not an reliable kind of protocol, and we make them reliable by attaching a TCP protocol. So TCP is a kind of transport layer protocol available at transport layer. So we'll be going to discuss it one by one by comparing the stacks. Stacks are nothing but the layer kind of structure. So if you're observing on the left hand side, we have the IoT stack, and on the right hand side we have the web stack. So web stack is related to your TCP/IP kind of stack, isn't it? So if I'm talking about the very bottommost layer of the TCP/IP stack, where the devices can be connected with the help of any wired media or wireless media, isn't it? So wired media, I'm talking about the Ethernet LAN cable. Okay, Ethernet 8.0 IEEE 802.3 is the LAN connectivity. There are again varieties of guided medias are there, just like a twisted pair cable, that is a shielded twisted pair or unshielded twisted pair, coaxial cable, fiber optics cable, DSL, ADSL kind of cable, which will provide you the higher bandwidth, ISDN. Then if I'm talking about the wireless connectivity, we are having a WLAN, isn't it? So IEEE 802.11, that is widely called as an Wi-Fi. So whenever I'm talking about wired and wireless kind of communication, so that can be a part of computer networks or TCP/IP model. But in IoT, we are totally rely on a wireless kind of communication. That is, we are having here the last and bottommost layer is a link layer, that is your physical layer. So here physical layer will be made up of only a kind of use of wireless technologies, not wired technology, isn't it? Because whenever we are having any kind of IoT development board, it should have a kind of wired technology, but normally a very small kind of IoT development boards that should be connected wirelessly to the each other. That is why WSN plays a very vital role in IoT, wireless sensor network. All the nodes which is having wireless capability, and that can be able to connect to each other and send the messages to each other. Now see here, the wireless technologies such as IEEE 802.15.4, isn't it? So this 15.4 is related to the wireless LAN, the low power, low rate data rate wireless LAN. Okay, and not only that, but also there are varieties of technologies are there, such as a Bluetooth, Zigbee, Wi-Fi, WiMAX, LoRa. All these kinds of wireless technologies will be the part of your physical layer of IoT, wherein TCP/IP, wireless, as well as guided media, LAN. Okay, that can be a physical content of your network. Next one, if I'm talking about the internet layer, that is the important most layer in both the stacks. Normally we can say network layer in TCP/IP or in ISO/SI layer, but in IoT it will be represented as internet. Means the devices can be connected globally to each other with the help of certain identification addressing scheme. So this particular addressing scheme, if in the TCP/IP is IP version 4 or IP version 6 or IP security. Okay, so with the help of this, your devices can get the identification on a network, just like we are having our own names. In the same way, the devices are having their own IP addresses, which is unique in nature. So here also in IoTs, we are totally rely on IP version 6. As we are aware about the drawback of IP version 4, IP version 4 is having a size of 32-bit, where IP version 6 is having a size of 128-bit long. Okay. So the total number of addresses generated by IP version 4 is only 2 raised to 32. But if you want maximum IP addresses, obviously we need to go for a higher version of IP address, isn't it? So IP version 6 is having a size of 128 bit long. So total number of addresses generated is 2 raised to 128, which is a huge one. And if I'm again considering the current growth of IoT, IP version 6 is also the generated IPs will be again lesser, because every individual, if I'm talking about getting a maximum smart devices with them, they needed maximum IP addresses. So IP version 6 will be again become obsolete after certain decades, and we want a new kind of addressing scheme. So currently researchers are doing work on this particular field. This is one of the challenges in IoT. We'll talking in details about what are the challenges available in IoT and how we can contribute to resolve these challenges. So IP version 6 and IP routing, and based on the IP version 6 we are having this particular very popular kind of protocol in IoT, which is a 6LoWPAN. So 6LoWPAN is nothing but it is a protocol uses IP version 6 only, but that will be using a low kind of power and to transmit the data, isn't it? Because everything is connected wirelessly to the each others, so they'll be sending a small amount of power. That is because in IoT, what is the important part? Your IoT development board should consume a less amount of power. So whatever the backup needed, which is very much lesser, and we need to use that particular battery backup power effectively. So we need to develop certain applications, certain protocols. It should consume a less amount of power, isn't it? So that is why 6LoWPAN is very widely used in IoT boards. Okay. Now next one, after the internet layer, we have now the third one is the transport layer. Transport layer plays a very vital role regarding the process to process communication. Means your data is broken up into small streams of data, chunks. We can say it's the data chunks, isn't it? So it can be again broken up into small pieces of data and will providing certain sequencing number to each and every packet. So session establishment, session then releasing, that can be a small part of your transport layer. Okay, so here reliability is provided, or we can say certain kinds of services, transportation services will be provided. In what sense? Now take an example. In TCP IP, totally we are rely on these two different very widely used protocols, TCP and UDP. TCP will be considered as a transmission control protocol, and UDP will be considered as your user datagram protocol. So we can use these protocol based on our applications, isn't it? Take an example. TCP is more reliable protocol. How? Because it always sends and receives the acknowledgement, always sends the packet or segments or chunks and get the acknowledgement, isn't it? Now it will be a kind of reliable kind of communication, just like a speed not speed post. It's a kind of registered post. Okay, once you are sending a letter to our friend, we are getting an acknowledgement letter also back. Your friend will was received that particular letter on which date at what time, isn't it? So in the same way TCP does work. It sends the packet and it will get the acknowledgement immediately. But in UDP that cannot be happen. So UDP will be considered as a faster kind of a data or a protocol where only data is broadcasted. It will never bother about whether the acknowledgements are received or not. Okay, no. Only it will broadcast the data. Just take an example of speed post, isn't it? We know that speed post also goes at the same kind of speed, just like your registered post, but you never get an acknowledgement of the speed post. But we can widely use this UDP in a different real-time kind of application because of the high speed. We don't rely on an acknowledgement. We are simply broadcasting the data. So in television broadcasting, we can use it. Okay. Or we can say in a video conferencing, we can use it, voice over internet protocol, where currently we are now connected, isn't it? So with the help of this voice over protocol, or we can send our audio or video real timely. We don't want an acknowledgement. Still, some of the packets are lost in a network, doesn't matter. But now see, whatever I'm talking, that is reflected at your end, isn't it? So whatever the packets generated by the device, it should be fastly transmitted. So here latency plays a very vital role, isn't it? Here two terminologies are there: latency and integrity. Latency and integrity. Latency is nothing but what? Latency is related to the time required to transmit the data or packets from source to the destination, isn't it? Without a small amount of delay, that particular delay will be considered as a latency. It should have lesser amount of latency. We want to minimize the latency, isn't it? But what is integrity, isn't it? Whatever I'm sending, it should suppose receive at different timing interval. That timing interval doesn't matter for me, but the data should be received without a single error. My data should be secured enough. Okay, in that case I can say it is the data is having high integrity. Okay, without suppose I am writing an email to you. Okay, so that data should be received properly, because that content in the email is very much important. Whether that mail can be received after 1 day, 2 day, or 5 day, doesn't matter, but the content will be error free, isn't it? So in that case integrity will play a role. In video conferencing, in real-time application, latency plays a very important role. I'm not bothering about loss of certain packets. I'm sending suppose 1,000 number of packets. From the 1,000 number of packets, if suppose 10 to 50 packets lost, that doesn't give the sense to your data, isn't it? My audio will be somewhat or video can be somewhat minimized. That is, the resolution will be somewhat low, but that cannot bother about the reproduction of the data or the video and audio. Now TCP, UDP, these are the different parts. Here also in transport layer in IoT, we are totally rely on the UDP as it is faster. We don't want the acknowledgement. When we take the help of the acknowledgement, means your waiting time is more now. Yes, reliability is obviously you are getting, but you are getting waiting time more. So we don't want it in IoT, isn't it? So your UDP is widely used here also. Got it? And I'm talking about the DTLS. So it's a data link transport layer security. We can provide the security to this particular transport layer also with the help of this particular newer protocol. Now talking about the last layer, that is application oriented layer, isn't it? Now in TCP IP, we can have a different application oriented protocol such as HTTP, that is widely used in browsing web portals, or HTTPS, that is a secured version of the HTTP. Okay, now we can have the DHCP, dynamic host configuration protocol, that will be useful for getting the automatic IP address that I have shown you in earlier Cisco packet tracer kind of application, isn't it? How the devices are automatically taken the IP address from the router or the gateway. The DNS is the domain name system, that is the name given to the IP address, because we cannot remember the IP address effectively. If I'm suppose having 10 devices or 100 devices, I cannot remember the numbers, but I can remember the names, isn't it? So that's why we are having our own name, so we can easily remember our names. The TSL, SSL. So these are the kind of security kind of things. So TSL stands for a transport layer security, and SSL stands for the secured socket layer. These are the some kind of encryptographic protocol that can be going to secure your application contents. Okay, in the same way, the protocols used in IoTs are totally different. Now see here, the COAP protocol, that is COAP, constrained application protocol. So in any kind of a constrained environment, suppose I'm having here very low bandwidth, isn't it? Or the network is, or environment is very much noisy. In that case, my IoT development board or any kind of development board can withstand with that particular condition. So I can use this constrained application protocol over there, isn't it? Next one, you can having MQTT. Okay, it's a messaging queue telemetry transport kind of protocol. So it's a kind of not a server client kind of protocol. These are the pub sub kind of protocol, isn't it? That is nothing but the publish and subscriber. isn't it? Means if suppose you are one of the server is having a publishing this content in one of the what I can say, the category, isn't it? And now suppose you are subscribed to that particular category, so automatically what are the messages are available in that particular uh, publishing content, those will be automatically delivered to you. So you can publish to multiple different kinds of choices. Okay, it's a kind of pub sub kind of thing. In the same way, we can having XMPP, that is widely used in WhatsApp and Facebook, that is extensible messaging and presence protocol. This is a very lightweight kind of protocol and can be able to share the data at a very fastest rate. Okay, so that is why we are using in a cloud. And AMQP is again somewhat similar to the MQTT. It's the advanced messaging queuing protocol, and one by one how the queue will be formed and that can be delivered. So we'll be going to discuss in details in a respective unit, but this is only an introduction kind of part. And once you have this application layer content, these are the important kind of things what is running behind this particular application. Now suppose in our mobile phones, Android mobile phones, we develop different Android applications, isn't it? So that can be based on certain Java scriptings. So very widely used JSON. I think you might be aware about the JSON scripting, that is Java scripting, object notation, isn't it? Or in the same way, we can have the CBOR, that is concise binary object representation. That is also based on a JSON file. Okay. So the background is the scripting language will be done with the help of your Java or in that particular coding. So we needed certain kinds of binary codings, and based on that we'll provide the support to your any kind of application protocols. And in the same way, we can having varieties of applications and their management can be done with the help of IoT stack. But in your WebSocket, the management content is absent. We are having simply certain kinds of backup at the backend side of your application. The HTML is widely used, then XML, JSON. Okay, so these are the widely used application for, that is for a language in scripting language. HTML stands for your hypertext markup language. Okay, so HTML is somewhat traditional way to remember all the coding parts or commands, and based on that we can design the somewhat attractive kind of web pages. In the same way, your web development in a TCP/IP works because your front console is your browser, isn't it? And at the back end of your browser, these HTML, XML, or JSON files will be working. These are these kinds of processes running behind your browser. In the same way, we are having certain mobile applications in our IoT developments, isn't it? So these are some of differentiation between TCP and the web stack. That is TCP/IP versus IoT. Now these parts we have already discussed. Now let us see what is the current status and future prospect of the IoT. Now if I am talking about, now see, on the x-axis we are having the years from 2003 onwards, now currently up to 2020. On a y-axis we are having the first parameter as a world population, the connected devices, and the connected devices per person. Now if I am observing in 2003, the population was 6.3 billions. Okay, and the total number of devices connected to each other will be only 500 millions. Only 500 millions, and that is every individual will be having 0.08 devices per person. Very few traditionally, isn't it? In 2003, very rarely we were using our mobile phones. I remember I purchased my first mobile in 2008. Before that, when I was doing my BE, so at that time there was very few mobiles were there, and rarely we have seen all these kinds of mobile phones, isn't it? So in the same way, now if the time increases, now see, when the years and years, now there is a era, new era, where IoT plays a very vital role. And now see this particular figure, every individual should have at least 6 to 7 devices. That is a prediction. Okay, up to 2020, every individual should uses 6 to 7 smart devices with them, just like your smart mobile phones, your smart gadgets, that is watches, bats, anything, specs. Okay, and now see the population is also increasing, and the predicted one is a 50 billion. Okay, now number of devices are connected to the network. IoT network is very much huge now, that is 50 billions. That is a prediction. And again, if you are going ahead, this particular count will be moving ahead. So now see, 50 billions means we needed a huge amount of what you can say, the IP addresses. Okay, so we needed IP version 6 is again becomes obsolete if we are marching ahead. But if my means you need to develop your own kind of addressing scheme, isn't it? So as we are moving ahead by selecting, because IoT only we cannot use in only consumer electronics, we can use in a industry as well, that is I square OT, that is industrial IoT. In the same way, we can have the next part as an internet of everything, just like internet of things, internet of everythings. Everything can be connected to the internet and can exchange the data. Okay, so huge devices, I'll be showing the application as well in next slide. Now see, what is the scenario if everything is connected onto the cloud? We can have your separate cloud. Okay, and varieties of sectors. Now I'll be talking about few sectors, I'll be showing this. Yes, now see the transportation, education, energy, that is a microgrid. You can have your businesses, e-commerces, homes, or everything. Every sector is now connected and can exchange the data. Now see, a huge amount of data can be generated, and that can be available on the cloud. Now what happened, now see, if 20 billion machines, now see, as earlier it is predicted in 2020, we can have yes, we can have 50 billion devices connected. Okay, so in the same way, if now see, 50 billion machines, if they are connected to each other and they are exchanging the data, now see, what the huge amount of data, what is the volume of the data? It's a huge amount of voluminous data is coming onto the cloud. Now how we can handle such huge amount of data onto the cloud? So we need to develop different algorithms. Okay, whatever the unstructured data is coming onto the cloud, we need to structure them. Okay, we need to fragment it properly, and you can save it in a sequential and proper manner. Okay, that particular management analytics will be having a separate domain of big data. How we can handle such a huge data, which algorithms can be used, how we can provide the proper security to these particular data, and how we can access the data depends on our requirement real timely at any time of. Okay, that is based on the applications. Got it? Now there is again if I'm talking about different applications of this particular IoT, now we are currently widely using this IoT smart boards in our personal wearables, such as gadgets, your smart specs, then your smart watches, smart bands. Okay, we are widely using it now. Every device is connected to the internet and uploading the data. So how it will be directly connected to the internet? No, what it will be doing, it will first connect the data or device to your mobile phones, okay, with the help of Bluetooth technology, and exchange the data on your mobile phone, and from the mobile phone it will be directly uploaded onto the cloud, as your mobile is connected to the internet, isn't it? Now these are the some of the devices currently we are using it. There are again many more, but here it is shown very few. Next one is a very popularly growing technology in a connected vehicles. How we can minimize the accidents. Okay, so with the help of the connected vehicles, how every vehicle can talk to each other with the help of the satellites or any kind of mobile technologies, 4G, 3G, or once your vehicle is connected to the internet, isn't it? So we can say that particular means your vehicle consists of an ECUs. This is a computing device. Means your computer is running on a four-wheeler, isn't it? So chances of hacking is very much the current trend, isn't it? Whenever you're talking about the connected vehicles, the hacker can take the access of your vehicle and can harm to your device or vehicle or a person in your vehicle. Okay, very soon we'll be observing an autonomous vehicle also. Means it's a vehicle will be automatically running on a way on a road. So we need to again uh, avoid such kind of conflicts. How to identify such kind of attacks done by the attackers or hackers, and how to defend it, isn't it? So there are varieties of ways the hacker can get into your system or a vehicle, because every system or vehicle is having an infotainment system which is directly connected to the internet. So through that backbone, the hacker will enter into your vehicle and can have a control on any section of your vehicle. Next one, the application widely used, just like your smart homes. So if you want to go for or create a smart cities, you need to first create our homes as smarter homes, where every appliances can be connected to your the gateways, and they can exchanging the data onto the cloud. And with the help of mobile phones, we can monitor the data, we can operate the devices at any instant of time. Okay, so smart homes is the small part of your smart cities. Once you create your home smarter, then automatically one by one, sector by sector, the devices becomes uh, more intelligent, and a huge amount of network, complex network will be created, and we can say this particular network as in smart cities. Okay, where varieties of domains will be connected to each other, such as we can have talking about the healthcare, logistics, all the different kinds of educational sectors, your industry domains, everything becomes a smarter ones. And now they'll be generating a huge amount of data, and that can be uploaded onto the cloud. Okay, so these are the some of the application oriented gadgets are shown or applications are shown. Now this one is over. Now we'll talking about in a detailed way what are the current challenges. Now you can also choose one of the challenge, and you can go for the B projects also. So these are the current research challenges we need to focus on. So am I audible currently? Yes. Can you write in the chat box? Am I audible properly? Okay, good. So means currently today we don't have that issue of voice breaking. Very good. Now let us talk about in details regarding the IoT research challenges, so that you can pick one of the challenge and you can work on it and try to solve the proper problem. Okay, and that can be your B project as well. So concentrate properly. The very first challenge is nothing but your naming and addressing. So as I mentioned, IP version 4 is almost obsolete in IoT domain. Totally IoT development boards will be using IP version 6, and very soon this IP version 6 will be again obsolete, because every individual will be requiring more devices. Okay, so again multiple numbering system or multiple IP addresses are required. So we need to go for the new version of IP address. Okay, so or you can develop your own kind of addressing scheme, so that IoT devices can be uniquely identified. Just like if any devices are manufactured, okay, any new devices are manufactured, manufacturer provides one unique number to that particular device, isn't it? So just like a MAC address of your device, physical address of a device, just like we need to develop our own kind of addressing scheme, so that we can connect or we can exchange the information to each other. Got it? Next one is a very widely and very huge challenge in front of IoT is the discovery. How the devices can be discovered. Now it depends on the range of your wireless enabling technology. Now if I am using, take an example of NFC. NFC is near field connectivity, NFC. Okay, that is a chip. Got it? And means very nearly the devices can exchange the data. Okay, so that is very near, just like we are having certain applications also. We can have this NFC chip in your credit cards, isn't it? So once you keep our credit card to the reader machine, automatically it will authenticate, or it will identify the kind of what you can say, the credit card unique numbers, and depends on that your transaction will be happen. Okay, so NFC. Now second one, we can have our Bluetooth. It will be having a distance of up to the 10 meters range. Okay, so any device coming between the 10-meter range, they can able to exchange the data. Now if I again want to increase the distance, now we can use Wi-Fi technology. Okay, it's up to suppose 100 meters range, 100 or 150-meter range. Okay, but again I want to increase my again the distance, means that is a kind of radius, means I'm talking about a circular distance, and that particular distance will be in radius distance, radial distance, isn't it? Now if I want to increase it, so I can go for WiMAX technology, WiMAX. Okay, Li-Fi. Okay, then I can go for LoRa. Nowadays LoRa is very widely used, is a low power radio frequency where the data can be sent at a very faster rate, but it will be using a very small amount of frequency, less frequency will be using it. So if I'm using a less smaller frequencies, the amount of power needed to broadcast the frequency is very much lesser. Yes, so we want to discover our devices, so we need to develop certain technologies, wireless enabled technologies, so the devices are easily discoverable. Now you can design any kind of technology, it depends on you. Next one, the third one, it is totally deals with the routing of data, how the data can be routed from one device to the destination device, or from the cloud to the device, and vice versa. Now routing protocols means because we are having varieties of in between network resources such as Wi-Fi routers, switches, networks. Okay, so how this particular packet, if I'm sending it, how it will cross the multiple devices, pass through the multiple devices, and can receive at the destination system. Now means what? We want to develop certain algorithm so that it will be finding out the least distance from source to the destination, so that it will send at a faster rate, isn't it? And otherwise what happened, your packet is wandering here and there, and it will take a maximum amount of time, that is the latency will be more, isn't it? So we don't want a latency, we want to find out what is the minimum distance from the source to destination. Every router is a smarter device, so it should have overall information regarding the network content, nearby network content, so that particular router will send the packet to its neighborhood which is having a least distance from itself. Okay, so in this way every router does the same thing, and now the packet can approach toward the destination with the least amount of path, so latency here will be reduced. Okay, so we need to develop certain robust fastest routing protocol so that your data can be sent at a faster rate. Okay, and it will be using a small latency. Next one, again is very important one. Nowadays we are facing a problems related to the power or the backup data the battery backup data. Okay, every IoT device will require sufficient amount of power to broadcast their data, because what happened, all the IoTs will be broadcasting the data wirelessly. Okay, so amount of power needed to broadcast the RF frequency signal is again a point of research. Okay, how we can use a minimum amount of power to broadcast your data wirelessly, isn't it? So your power management, that is power efficient sources management, that is again a very important part, because nowadays we are using a very we can say varieties of uh, non-conventional energy resources or conventional energy resources, how we can generate the automated kind of energy, how we can save the energy from the solars, we can use solar panels. Okay, and directly the power, the actual power will be provided directly to the IoT development boards, so no need to give the or provide the power using the storage backup. Okay, directly the data, the power will be taken up from the solar panel directly. Okay, no need to installation of the batteries and all the things. Now the next one, again, the challenging part is a big data analytics. How we can manage the data, the huge amount of bulky data, if it is coming onto the cloud, how we can manage it, isn't it? So we need to find out the certain statistical structuring, how the data is looking and how we can make it and form a structured way, some certain kinds of blocks, and how we can save it, okay, onto the physical memory constraint. Okay, that is again a big issue. So currently widely used Hadoop is one of the application through which we are going to do the analytics on this particular big data. Next one, the heterogeneity or dynamics. Whenever I'm talking about the heterogeneity, so any devices will be capable of sending and receiving the data with the different technologies. The different technologies such as, take an example, suppose I'm having a Raspberry Pi as one of the IoT device. Raspberry Pi supports the Bluetooth also, Wi-Fi as well. These are the two different technologies. So these are the heterogeneous technologies because they will be using their own kind of frequency spectrum, isn't it? They're not going to interfere with each other. Means if a data is coming on a Bluetooth, so device should be capable of processing the data and send the data to the Wi-Fi or through the Wi-Fi. So these are the heterogeneity platforms available. All the IoT wireless enabled technologies should be incorporated onto the single development board. Or we can say that if nowadays we are having 4G, 2G, 3G, 4G, isn't it? Now also we are having a CDMA kind of things. Okay, so if suppose a call is connected to the CDMA, how I can move and switch to the GSM if I'm moving from the one cell to the next cell. So that kind of what you can say, the handover should be possible. So that is called as a heterogeneity of devices. Next one, the scalability. Now again is a very important issue. Scalable. The network should be scalable. Means what? Now suppose I'll be taking one example. Currently suppose 10 devices are connected in a network. 10 devices. Now I have designed the network, everything, and now all the devices are properly communicating with each other with the use of any wireless enabled technology. Take an example of Wi-Fi. Okay, now suppose 10 mobiles are connected to the Wi-Fi router using your Wi-Fi technology. Now take an example, after certain days, suppose 100 new mobile phones or IoT devices are connected to that particular network. So is your current network can sustain that much amount of load onto your device or on your network. So that is a scalability. If in future, if the number of devices are connected to the same existing network, whether your network can withstand with the new devices or the strengths, that is scalability. Okay, now that is again a new issue. Interoperability again in the same way, kind of a heterogeneity, the communication from one wireless technology to the next is the kind of convergent kind of protocol. See, if suppose one of the devices is using IP version 4 and other using IP version 6, so that should have a kind of a conversion in your IoT development board. IP version 4 packets are converted into IP version 6 and that can be transmitted to the destination so that every device is properly communicating with each other by their own kind of protocols. Okay, that is a interoperability kind of communication. Obviously, security and privacy is a very important aspect in IoT. And for your kind information, IoT is not that much secured, isn't it? So you are having a very huge scope here to work, because whenever I'm talking about the hardware platforms in IoT, because I'm talking about the second most layer, data link layer, isn't it? So here there's a wide scope and very little work is done in this particular area because it's very complex, the device oriented. Because whenever I'm talking about network layer and all the above layers, because we are dealing with the software kind of version, software it is very much easier to create our own kind of encryption algorithm. But whenever I'm dealing with the bottommost layer, physical layer, data link layer, these are the hardware orchestrated layers. So the security provided to the hardware orchestration layers is very much difficult. Okay, so we are having a very high chances of hacking in this particular. Any hacker can take easily the control on any IoT development board and can change the data or can upload any wrong kind of data onto the cloud. Okay, that is again a variety of the new challenges. Next one, your device or IoT device should be a fault tolerance. So how you can design a certain techniques to resolve these faults automatically. The self-adaptivity. The self-adaptivity. Whenever the noisy condition will be there, now whether your IoT development board will be selfly adapted with the new technologies or new environment. So just take an example. Currently, we are having a AI or machine learning kinds of algorithms. So it will able to identify. They will be going to get the information and accordingly it will behave, isn't it? So that is kind of the fault tolerance will be generated or that can be predicted. Got it? So AI and ML can be helpful in IoT, and very soon it will be used combinedly in all the different domains also. And finally, the congestion control. Again, it's again one of the very much important challenges. If huge amount of data is coming onto the cloud, how the devices are congested, your network is very much congested. So how to resolve this conflict? Now see, if you are browsing a Google, whenever you want to check the internet connectivity, simply we can go to the browser and write the google.com simply. So you cannot imagine how much amount of data, the huge voluminous data is coming towards the Google server or Google cloud. How Google cloud will going to provide the solutions or the responses to these solutions or the queries coming now in such a way that you need to design certain congestion controlled mechanisms. How to avoid the congestion or how to predict the congestion and how to avoid it. Just like you can have, I think, CSMA techniques, carrier sense multiple access. So we can help with the help of carriers, we can going to sense the medium and check what is the condition of current network medium. If it is congested, so we need to defend, we need to predict, we need to hold the transmission of data. And whenever it is free, then you can broadcast it. So there are varieties of techniques are available. I think you might be studied in your computer networks soon in second unit as well. Okay, or I think in at third year level you have studied it. CSMA CD, CSMA CA, that is carrier sense multiple access, collision detection and collision avoidance. Instead of detecting it, why not we can predict the collision and you can avoid it. So these are the techniques you can widely used in wireless technologies. Got it? So these are the some of the challenges, and I think everybody should uh, search the content onto the Google platform and find out at least one problem, or that is a problem definition, okay, related to these challenges, and you can get your or design your actual current project